We perform whole exome sequencing on all of our patients who are diagnosed under 5 with IBD. And we do this because there's a very strong genomic driver to the disease. So the genes play a huge role in the disease for the very young children, way more than it does for older children and adults with IBD. And we were able to look at massive numbers of patients as well as their parents. And it's under a research basis, so from a research perspective, we could look at all the different genes that are involved, but it's translated to patient care because whoever has a positive finding, we take them out of the research part of the protocol and then we change their therapy. And so with that, we've identified conclusively in 14 of our patients that there's a single gene that's responsible for the disease. So it's totally changed our ability to care for these patients. You can't provide the right care if you don't have the right understanding of what you're looking at. So if you don't know the relevance of the gene that you find, it might mean something or it might be totally a common thing that's not important. And I don't have the know-how to bioinformatically decide that.
The abilities that we have here are just different than what other institutions have. And it's very frustrating because to us what should be straightforward, namely pulling every CBC on every oncology patient when we hand you a list of patients, which here takes, a day. In another institution, we've been working on it for a year and we still don't have the data. The clinical informatics structure here, infrastructure that we have at CHOP is an extraordinary resource that has allowed us to begin to tackle questions that we would not be able to tackle otherwise.
So I use what we've discovered on the research side of the genomic alterations that are getting identified in pediatric brain tumors, and where we're translating that onto the clinical side is the clinical diagnostic panels that we're using are actually also generating new information. So rather than having this arbitrary, here's a research finding, here's a clinical finding, we're actually able to put both types of data together, capitalize and use it and really make it meaningful, meaning that I can use it to help take care of patients, which is kind of why we're all in this and why we're all doing this.
About 4 or 5 years into our experience with electronic health records, I came to realize that my colleagues who had pursued research careers were suddenly having troubles getting access to the information that they needed to do their projects. And I, once again, calling on my technical background, said, well, that information exists. It's in the electronic health record. You shouldn't be going through charts, reading lines and lines of text. We should be extracting that for you electronically. So I began at first just as one person extracting health data for researchers, and then we built a whole team around it, and this has become a very large part of not only what our institution does, but what institutions all over the place do, which is to try to make the best use of electronic health records to make important discoveries about child health and discover new ways to improve health outcomes. Now at this point I'm actually really interested in predictive modeling and how do we use the enormous amount of data that's now available to predict health outcomes in a way that's useful. It's really a great age of opportunity for health informatics researchers to find many different opportunities to improve health for patients, and I'm very excited by that.